how do you compare antennas? And that's something we'll spend a lot more time in lesson 4 talking about antennas. Antennas, you see, you cannot really talk about milliwatts because there is no electricity coming out of the antenna. There is an electromagnetic field, yes, but it's just a potential. No, it's a magnetic field due to these electrons moving. If you put your tongue next to the antenna, you're not going to be getting a jolt, right? There is no real electricity coming out. And anyway, what we want to do is to compare antennas with one another. So the easiest way to do that is to take a reference, just like we did with the 1 milliwatt reference. And that reference is a theoretical imaginative antenna that we call the isotropic antenna that you see on the screen. That isotropic antenna is a theoretical antenna that is 1 point, 1 dot large, and that radiates exactly perfectly the same way in all directions in the sphere. Okay, that's the isotropic antenna. It does not exist in real world. Why? Well, because we can't make things that are 1 dot large. We don't know how to make that. Even if it's 1 atom, it's more than a dot, right? An atom has a size that you can measure. And also, sending all directions the same energy is not something we can do either. Simply because you have to make that antenna out of some material and you have to bring energy into that antenna. So just by the making of the physical structure of the antenna, there will be some places where you will not be radiating the same way than the others. You won't send where you receive antenna energy, for example, and you may be sending more in some sides than some others, just because of the making of it. So the isotropic antenna doesn't exist, but it doesn't matter, because what we want to do is to compare things to a reference. And that allows you to say if that antenna is that much compared to the isotropic, and this one is that much compared to the isotropic, then I can compare these two antennas together, and that's all that matters. That gives us what we call the dBi scale. Decibel again, but the reference is not 1 milliwatt, it's the isotropic antenna, dBi. So if you have an antenna that has 4 dBi, and the other one has what we call 8 dBi, and we call that gain, and we'll come back on that more extensively, you can compare these two. Of course, the isotropic doesn't exist, but you know that one of them is twice as powerful as the other, right? No, it's not, because it has 4 dB, remember? Twice is 3 dB. That was the trap. 3 dB is twice. So if you go from 4 dBi to 7 dBi, yes, that would have been twice as powerful. But because you go to 8, it's more than twice. And again, that's where you would need an online map to exactly calculate 4 dB, how much that is. It's going to be about 2.5 to 3 times more powerful. But the idea is that you can compare these two antennas together because each of them can be referenced again, that reference point, which is the isotropic antenna. Some people don't like to use the isotropic antenna, less and less today, but you'll still find people saying, it's not fair, you're using an isotropic antenna, there is no such thing, so why use as a reference something that doesn't exist? If I talk about 1 milliwatt, there is a 1 milliwatt current, so let's use something that exists. And they use as a reference the simplest, more basic antenna you can make, which is called a dipole antenna. It's also called a rubber duck. It's the cheap antenna you can have with a cheap Wi-Fi hardware. And basically that antenna has a radiation pattern which is not exactly perfect, but it's simple. And we can compare it to a dBi antenna anyway, because a rubber duck is 2.14 dBi. So using one scale or the other doesn't matter. If you see something in dBd, dB reference to the dipole instead of dBi reference to the isotropic, you can just remove or add 2.14 to move from one scale to the other. So it's the same scale, it's the same log, it's the same rule of 3 and 10, etc. You just have a different starting point. Instead of starting from ground zero, you start from 2.14, and that's it. So that's pretty simple. So if you have a 5 dBd antenna, you can say, well, okay, 5 dBd, that's plus 2.14, 7.14 dBi antenna. Okay? Either way is fine. As long as you know which scale we're talking about, you can move from one scale to the other. So a 5 dBd antenna, that's twice as powerful as what? Think about it for a second. And if you thought about the rule of plus 3 and minus 3s, you were right. It's twice as powerful as something that's 3 dB less. So 5 dBd, that's twice as powerful as something that is 2 dBd. And because 5 dBd is 7.14 dBi, it's the same thing. I think it's twice as powerful as something which is 4.14 dBi. It's the same scale. We're saying the same number, just with a different reference. Okay, enough of theory. Let's get on the board and do some exercises together to make sure you get that rule right.